I am JNCIA, and for today's video is I am going to demo the laboratory number 8, which is the JNCIA or the Juniper certification. I will be the commentator of the video of Naj Kazi, if I pronounce it correctly, with the title Static Routing Overview and Configuration. So let's watch his video.
So a static network route or static route is composed of two different pieces. Piece number one, it's a manually configured route that defines a subnet or an entire class A, B, or C network. Next, you can either specify an outgoing interface or a next hop IP. So here's how the syntax looks. On the router, and we'll do this in CLI in a moment, here's what we type in. On the router, we type in IP route. We specify the network that we need to specify. We specify the subnet mask of that network. And then finally, we specify the next hop IP address. So the next hop IP, this is the subnet mask, this is the network address, and then these are the keywords, IP route. And that's how we create a static route on a router. Here's another example where instead of the next.
So a static route is a manual configuration of routes where two routers can access each other even they are not on the same network. So sa may number 2 is sabi niya, next you can either specify an outgoing interface or a next hop IP address. So sa may syntax niya is yung IP route mismo, that is the command for our static routing, and this is the network of the router that you are configuring, and then yung subnet mask then nung router na kino-configure mo, and lastly yung IP address kung saan yung router na gusto mong puntahan, or sabi niya nga is yung next hop IP address.
Hop IP, we have the local interface specified. Specifying the next hop IP in the static route is considered a best practice design. Specifying an Ethernet interface, for example, is not considered good, because if it's a point-to-point interface, you're fine. But if it's not a point-to-point interface, and if it's like an Ethernet segment with multiple devices on it, every single time you're expected to route traffic to that interface, it's going to generate a broadcast, and that broadcast will be sent out to all the devices. So it's not considered good practice to specify an interface. Instead, you should always have a next hop IP configured. Reviewing the show IP route command shows a different output in the routing table for each of the static routes configured above. So what I'm saying is that for each of the IP route statements that we have specified here, whether we have the next hop IP or the interface specified, the output is going to look different, and I'll show you that in a moment. When the router interface associated with static route fails, the router automatically removes the static route from its routing table. So now let's quickly go to the CLI and look at this stuff. Now let's quickly take a look at this routing scenario here right in front of us. So about router 1 right now, and I'm gonna go ahead.
So yung diagram niya is for the router 1 ang network, for the router 1 and router 2, or the router 1 connected to the router 2, ang network niya is 10.0.0.0 with a subnet of 30, and merong dalawang interface na present sa R2, which is the 192.168.0.0 with the subnet of 24, and also the network of 192.168.1.0 with the subnet of 24.
And take a look at show IP interface brief to see what's going on. And it seems like
So, yung command nyo dito is the SH or show IP interface brief, wherein dito is pinapakita niya or sinushow niya yung interfaces na meron dun sa router natin. So, for the router 1, meron siyang tatlong interfaces, the gigabit 0, 1, and 2.
I have an IP address of 10.0.0.1 configured. See if I can ping the other side, which happens to be 10.0.0.2. And it seems like I'm able to successfully do that.
So, for the ping, yung ping naman is to check lang if may connection in between two interfaces or devices.
So router 1 is able to ping router 2. Now router 2 happens to have a couple of different routes. 192.168.0.0/24 and 192.168.1.0/24. Two separate subnets behind its LAN. Now router 1 by default is not going to have the ability to see those routes. To verify that, we'll look at show IP route. This is the routing table. And as you can see here, routing table has this codes section. So what we can see,
So, in this show IP route command, dito naman makikita yung mga different types of IP routing. We have the EIGRP, RIP, as well as the OSPF. And also makikita mo dito if may existing ba or walang existing na IP routing configuration.
right below that is the different networks that are in our routing table. And C corresponds to the flag or the code up here in the table, which stands for connected. So this right here is a connected route, and it's on our interface gigabit 000, and this happens to be the /30. Our local route, which is the L flag here, is 10.0.0.1/32. Now this is called a host route because it's a very specific route. It's a /32. And it's also directly connected over gigabit Ethernet 000. So if you guys remember the administrative distance chart we were looking at, this has an administrative distance of 0 because it's directly connected. It's considered to be the most believable. Now, we got a bit of a problem here. We cannot see the routes that router 2 has, these 192.168 routes. Now, before we do anything, let's quickly jump to router 2 and look at show IP interface brief, make sure everything is up and running. And indeed it is. And what I've done is I'm representing these.
So, just a brief explanation kung ano ba yung ginagawa niya. So, sa router 1, meron ng connection in between the two interfaces, which is the 10.0.0.1 and the 10.0.0.2, because they are connected or directly connected to each other. Ngayon, yung two interfaces ng R2, ang gusto ni Kazi is maping ng R1 yung two interfaces na connected dito sa R2, which are the 192.168.0.0 and the 192.168.1.0. So, he will use the static routing in order for the router 1 to ping the two interfaces of the router 2.
Routes as loopback interfaces, because it doesn't really matter. I mean, I could have other layer 3 devices hanging off of this router if I wanted to, but I'm just trying to simplify the configuration here, and it doesn't make any difference whatsoever. Let's quickly take a look at show IP route. So if I do that, I will see that I have a bunch of routes that I've specified. Once again, for every route that, or for every interface, I'm going to see two different entries. One is the host specific entry, and that has a flag of L right next to it. And then I'll see another entry, which is the C entry, the connected route. And that is the network that I specified when I was configuring my interface. So let me quickly show you what I mean. So if I were to do show run, let me show you how I've specified these interfaces. Loopbacks are /24s.
Yung command niya kanina is show run, wherein makikita lahat ng interfaces, lahat ng configuration na meron dun sa interface. For example, this one, the interface gigabit Ethernet 0/0/1. So wala siyang IP address, naka-duplex pa siya, and speed is naka-automatic pa rin, and naka-shutdown siya. So meaning, hindi siya up.
As you can see here, the gigabit 0/0/0 is actually a /30 because it ends in .252. Now, if I were to look at the show IP route, the reason we're seeing the loopbacks with /24 and /32 is /24 represents the subnet that I typed in here, right, which was .0. But because I have specific IPs on the interface, it automatically inserts a host route. So this is not something I inserted. This is the operating system automatically inserting the host route just so it has a specific entry in its table. So I just wanted to quickly point out that distinction. Now let me jump back to router 1. We still have a problem. I can't ping, for example, one of these subnets that router 2 has on its LAN side. And I'll prove to you that I can't ping either one of them. Both networks are currently unavailable on router 1. And the reason is router 1 doesn't know where those routes are, and hence is unable to get to those destinations. So let's go ahead and enter those routes manually. That's what's called static routing. We'll go ahead and set that up. So IP route 192.168.0.0. Then I'll type in the subnet mask, and finally I'll type in the next hop IP here, which for us is 10.0.0.2, which happens to be the router 2's interface pointing toward us.
Here, yung IP route na ginagamit niya is the IP route, and then yung 192.168.0.0 is yung interface na meron sa may R2. Now, yung subnet mask, so yung for the subnet mask ng interface sa R2, and then yung 10.0.0.2, yun yung interface na connected doon sa R1.
Now let's go ahead and do ping 192.168.0.1, and voila, we have much better luck this time around. Now if you were to look at show IP route, you'll clearly see that we have an S flag which stands for static, meaning I manually typed it in. And as you can see, it clearly spells out the network address, the subnet mask, and the fact that it has an admin distance of 1 and metric of 0. So it's very, very believable. Of course, directly connected will always be preferred, but then right after that would be the manually typed in static route.
So, yun, pining niya yung 192.168.0.1 after niya ma-static routing. And sabi niya dito is, success rate niya is 100%. So, meaning, nagkakakitaan na yung R1 and then yung other interface or the interface 1 nung R2.
And it specifies the next hop IP that we typed in of router 2. Let's go ahead and now add the other route, IP route 192.168.1.0, 255, 255, 255.0. And in this time around, instead of specifying the next hop IP, I'm going to go ahead and specify my local outgoing interface toward router 2. And as you can see here, the operating system on this router is giving me a grief. It's barking at me. It's saying default route without gateway, if not a point-to-point interface, may impact performance. And that's what I was alluding to earlier, that we're going to have a lot of ARPing going on. And if it's not a point-to-point link, we might have performance issues.
So, ang ginawa niya sa is pag-static routing niya is ang in-specify niya dito is yung interface nung gusto niyang nung next hop IP address dapat yun is yung next hop IP address ang nilagay niya imbis na yung Ethernet imbis na yung interface. Bakit? Kasi mas marami pang dadaanan yung gigabit yung interface kapag ginamit niya yung interface. So kung may interface na gigabit 0/0/0 yung router 1, dadaan muna siya doon bago siya dumaan doon sa tamang interface kung nasaan yung next hop IP address na tinutukoy niya rito.
Because our ARP table is going to get pretty big and we're going to have broadcasts going to different devices. Now let's go ahead and look at our show IP route again. And this time around, as you can see, it appears in our routing table a little differently. The first part is the same, so the network and the subnet mask is the same, but this time around it says it's directly connected. And once again, directly connected is preferred over the static route, but remember, this is not a good practice. This is actually a bad design to specify a next hop interface instead of the next hop IP, but I just wanted to show you two different ways of doing this. And one final thing is to do a quick verification check and make sure we're able to reach the new subnet that we just added. And indeed, we are able to do that. Now let's quickly take a look at show ARP. And sure enough, we have those IPs specified in our ARP table.
So, yun, balik tayo dun sa may ayan. So, dito pining niya yung 192.168.1.1, meaning isang interface na nandito sa baba. Hindi natin nakikita. So, yun, pining niya. So, ang success rate niya is 80%, which is okay na. Napiping niya na yun. And then, kapag inulit mo ulit yung iping, magwa 100% na yun. So, yun lang. That's all for this video.